Hey there everybody, welcome back. In this video we are starting our next unit on inequalities. Through the course of this video, I'm kind of hoping that you should be able to understand and be able to do these things. So at the end, if you want to come back and double check that those four things make sense, that would be a good idea. So we're talking about inequalities, and inequalities are a lot like equalities or equations. A lot of the same rules will apply to each of them. So there's two ways that we're going to talk about solving these inequalities. The first is to just go ahead and use algebra, see what we get. And the second is to do it graphically. Okay, so the first example here, I've got 2x minus 3 equals 5. Obviously, if I want to solve that, I'm just going to work through in reverse. I'm going to add 3 to both sides, so I get 2x equals 8. And then I divide by 2, and so I get x equals 4. And so we go. If I have an inequality, for example, 2x minus 3 is greater than 5, it's not equal to 5, but I can still use all of the same algebra rules that I know and love. So add 3 to both sides, and I get 2x must be greater than 8, and divide by 2, so I get x must be greater than 4. And so all the same rules that we have for algebra apply if you want to subtract, add, multiply, divide, square root, whatever you want to do. The only thing we need to be aware of, and so I'll make a little note here, that the only thing we need to be aware of is if we multiply or divide by a negative number. If we multiply or divide by a negative, we have to remember to switch the inequality sign. And we'll see some examples of that more so in the next video. Okay, so if you ever have to multiply or divide by a negative, just swap the inequality. A less than becomes a greater than and vice versa. So working algebraically with inequalities is really straightforward, but often we want to just demonstrate them graphically. So if I have a similar, not quite the same equation as I had before, but now I have a function. So for example, y is equal to 3x plus 5. I can graph that. That is straightforward. So I know that my y-intercept is 5. 1, 2, 3, 4, 5. So I've got that point there. And if I go over 1, I have to go up 3. I'm kind of off the grid there. But if I go over to the left one, I go down 3. And over 1 and down 3. And I can see here that my line is kind of like this. So there is my line. That line continues on in both directions forever. So this line represents this equation that I have here. And so if I have an inequality, like for example, y is actually greater than or equal to 3x plus 5, what we're saying is it can be equal to 3x plus 5, or it can be anything greater than that. And so I would graph my same function. And so I'll just plot these points here, over 1, down 3, and so on. And so I've got the same function that I had before. But what I'm trying to say is that actually it could be on this line. So y could be on this line, or it could be anything that's greater than that line, or anything that's above that. So in actual fact, what I'm going to do is I'm going to shade this whole area which is above the line. So the solution doesn't just have to be on that line. It could be on that line, or in fact, anything above it. The last example here is now look at this one here. We've got the same graph, but now it's only greater than 3x plus 5. So what that means is it can be greater than that line, but it can't actually be on that line. So it's the same picture. So I'm going to start with this, my same points that I had here, okay? Except to show that, that it's not actually on the line, I'm going to use a dotted line here for my starting point, kind of my first line. And then I'm going to shade in everything that is above that. So if we have a greater than or equal to sign, or a less than or equal to sign, then we have a solid line. And if it's not equal to, it's just greater than, or it's just less than, then we use a dotted line. And basically we're just saying in this case, it's not actually on the line, but anything above that's good. Whereas in the other case, it could be on the line. Okay, so let's look at a couple of examples. So we're going to graph the linear inequality 2x plus 3y is less than or equal to 6. And we're going to determine if -3, -2 is a part of the solution. So the first thing I'm going to do here is I can graph this if I have it in slope-intercept form. So I'm just going to rewrite this as 3y is less than or equal to -2x plus 6. And then I'm going to divide by 3 and divide by 3. And I'm going to get y is less than or equal to -2/3 x and then plus 2. So my first step is to create the boundary solution, which is the line that's going to describe that inequality. So y, basically the line y equals -2/3 x plus 2. So I know my y-intercept is going to be plus 2, and my slope is negative, which means as I go to the right, I'm going to go down, and the slope is 2/3. So for every 3 I go over, 1, 2, 3, I'm going to go down 2. And over 3 and down 2, and so on, over 3, down 2. And I can kind of do the same thing going this way, over 3 and up 2, over 3 and up 2, and so on. And so now I've got my line. Since it is less than or equal to, then I'm going to include this line as part of my solution. So I'm going to draw a solid line through here, so it can include anything that's on that line. Now, you might visually be able to look at this and tell me, oh, well, less than will be above the graph or below the graph, or maybe you can do it visually. But if you can't, an easy way to do that is to pick a point like they suggested here. So they're saying pick this point and tell me, is this part of the solution? So is -3, -2 part of the solution? So let's just find that point right there. Okay, so -3, -2 is 1, 2, 3, and then down 2. So there's my point, -3, -2. And they're asking, is that part of the solution? Well, all I would need to do is substitute that back into my original inequality, and if it holds true, then I guess it's a part of the solution set. So I'm going to put in -2 for y, and I get -2 is less than or equal to -2/3 times -3 plus 2. So let's see here. I have -2 is less than or equal to -2/3 times -3. I guess that negative sign is going to cancel, and then 2/3 times 3 is just going to be 2 plus 2. So I end up with -2 is less than or equal to 4. And so the question is just, is that correct? Is -2 less than or equal to 4? Well, yes it is. And so that means that this point is part of my solution set. The nice thing about this is, you know that since it's a line that's going to just divide your plane into two chunks, they're sort of above the line and below the line, there are no other spaces to talk about because this line again goes off in both directions to infinity. If that single point is part of the solution set, then that means everything in this region must be part of my solution. So all we really need to do is test a single point for a linear inequality, and if that one point ends up being correct, then we know everything on that side of the line is part of the solution set. And if it's incorrect, then it must be everything on the other side of the line. So let's now take a look at this. Let's work backwards. So let's go from this, this picture and see if we can come up with the inequality that works. So, okay, so I've got, the first thing I can recognize is I've got my boundary line here. So I'm going to write that, I'm going to write an equation for that. That's kind of in the form y equals mx plus b, okay? And so I can see here that my y-intercept is going to be +1. And I can tell that my slope, I'm going over 1 and up 2, so 2 and 1. And so that I can see there that my slope must be 2. So this must be y is equal to 2x plus 1. So that's my boundary condition. But of course, this isn't going to be an equation because it's an inequality. And so we've shaded one region and not the other. So what I might do is I might just pick a point just to compare, and you can choose any point you want, but what I might do is I'll choose a point that's in the shaded region, and then I'll just see what that tells me about my inequality. So you can pick any point you want. Maybe I'll choose this point right here. So I'll choose the point -2, 0, because that is part of the solution set. And I'm going to substitute those numbers in there. So I would get 0, and I'm just going to leave this blank for a second, and then 2 times -2 plus 1. So I've got 0 and then negative 4 plus 1. So that's 0 and then negative 3. And so all I have to do is think about, well, what sign can I put between 0 and negative 3 so that this is correct? And we can see that 0 is greater than negative 3. And so that must be the sign that I'm going to use. I need to make a decision then, is it going to be greater than or equal to? And I can see from the dotted line that the dotted line means it's not, the line itself is not part of the solution set, so I'm only going to leave it as a greater than. So I can take this sign here, and I'm going to bring this back into my equation and put it in there, and say that this inequality is y is greater than 2x plus 1. And that is the inequality that's shown by that graph. Okay, so that is it for linear inequalities.